Okay, I'm going to quickly go over some of the concepts in coding theory. We'll start with assignment. Assignment is when we're assigning a value. The CIE method is to use an arrows. This would read y is assigned the value of 6, but we can also see it as x is assigned the value of 5 by using the equal sign in some of the pseudocode examples. If we're going to input data to a variable, we can use input answer, which would input the user input to answer. This is in pseudocode. And output score. This would output the value from score, from a variable score. Or we could use output your score is, and then we could concatenate it with the value of a score. So either of these will work. We have selection, assignment. Sequence is one instruction after another, and then we have selection and iteration. So selection, there's two methods of selection: an if statement, if then else and end if, and a case statement, case of, otherwise, end case. So first of all, the if statement. The if statement we're normally familiar with would be something like x is assigned the value of 5. If x is greater than 3, if this condition is true, then we do something. Else, if the second condition, then we do something else. Otherwise, if neither of these conditions is true, then we do the final thing, and then we end our if statement, and these are all tabbed over. We have a choice statement, or a case statement, which allows us to input some value. In this case, we've got a variable called choice. We might display a menu, and which gives a list of operations. Then the user is prompted to enter a value, choice. In this case, it'd be 1, 2, 3, 4, or 5. And so we input the choice, and then we say case of choice. This is our variable. 1, then we call a subroutine multiply. 2, we call a subroutine divide. 3, call a subroutine subroutine subtract, add, and end. And then we end this case. Now this is the equivalent of a nested if statement. So the value here is the value of choice. So we're evaluating the value of choice. Choice will either be 1, 2, 3, 4, or 5, and given the value, we will do this. This is where we could have, I didn't include it in this case, we could have used the keyword otherwise, and otherwise would have been the same as an else statement, the equivalent of an else statement over here, and it could have been otherwise, and then we could have put in another condition. So if none of these conditions were true, that's when we would use otherwise. So this is the logical equivalent of this in an if, and a case statement is just, case statement is just a shortcut for a number of if-else ifs. So I could say input choice, choice equals 1, then I do this, choice equals 2, I do that, choice equals 3, I do this, 4, 5, and then I end it. So this is a logical equivalent of this case statement here, and that's what a case statement is for, is to give a shortcut to this when we have a list of selections. We have three types of loops, which we should be familiar with now. We have the for loop. This is when we know how many times we want to do something, so we set a counter. We know when we're going to terminate it. The default step is incrementing by 1. We could step it down or up by down by 1, up by 2, down by 2. We could set the step. We do something within the loop. We end the loop with the next, and we can put the name of the counter in here. The logical equivalence of that statement with a repeat until loop. Repeat until loop. We do something until the condition is true. So this is an exit condition. We check the condition upon exit. So we'll do it at least one time. So I set the value of count to 1. I repeat. I input A, and then I increment myself, the counter, and I'm doing it until the counter is greater than 1000. So this is the logical equivalent of this. The while loop we have is we do something, and then we check the condition upon entry. So I check the condition upon entry. Here I've got the condition upon exit. So I set my counter to 0. While count is less than 1000, I do something. This do is probably optional. While this condition is true, then we get end while. The different languages implement a while loop in different ways. Some do use the keyword do. But anyways, what I'm doing here is I'm incrementing the counter, and then I'm inputting values. In this particular one, I'm inputting the value into an array. So this is the logic equivalence of this, the logic equivalence of this, in the 3 types of loops that you need to know. Data structures, there's only one data structure we're interested in, that's a one-dimensional array. And I can do an array declaration like this. I can write declare student names, which is an array 1 to 30 of type string. This is also acceptable by just putting the max in here. You could probably get away with just giving it the array name. I have seen in some instances being able to do student names, then the max, and sometimes you might as well give the data type, but that's not always required in all of the MARC schemes. So I can define it here. I haven't often seen the use of this keyword declare. This comes once again from the exam board's pseudocode guide. And this is how we use an array. We loop through it. For index, assign the value of 1 to 20, and for instance bus times. The index will increment, and I'll assign the value time to the to that element of the array. So here's some past exam questions. So these are types of questions you might get. Counting and totaling are on the syllabus. These are the key things that you have to do in your syllabus for programming. So here's counting. So amount, assign the value of amount plus 1. So I'm counting the number of something, so therefore I'm going up by 1. Repetition, there's my for loop. Selection is my if statement. And totaling, sum is assign the value of sum plus the next value I read in. That's totaling. And this was the original question. There's the answer to that question. Another type of thing you might get, write an algorithm using pseudocode and a for to next loop structure to input 1,000 numbers into an array. So we simply we write for count, assign the value of 1 to 1,000, input the value, next count. And then it's rewrite your algorithm using another loop structure. We already looked at these 2 loop structures. And this is how the marks are assigned. You initialize it, you start the loop, you update the counter, and you end the loop. So for all the loops, these are the things that happen. There's my initialization, and I start it, update the counter. The for loop is updated here. I have to explicitly do it in the other 2 loops. That's my updating the counter, and then I terminate the loop here. I terminate the loop when this condition is met, and I can terminate the loop when this condition is met. So here we have something on data types: integers, reals with decimal places, chars, single character, a string, and boolean, true or false. Variable and constant. So these are the other 2 things you need to know. It's used to store data that can change during the running of a program. A constant is used to store data that will not change during the running of a program. And this question here, identify different loop structures that you can use. So it's worth 3 points. You can write it like this, but I might be inclined to give an example of a for loop, an example of a repeat, and an example of a while for that. Another question from a past exam, counting, totaling. I think this might be the same slide we've seen. Repetition and selection. And what have we got here? This is the same one. Yeah, those slides are duplicated. So that is that's the majority of the coding theory you'll need to know. There will be some kind of question on that on paper 2.